Hey everybody, welcome to week 6 of Advanced Java Programming here at Florida State University. So we're kind of in the the last couple weeks of the course here. So you've already gotten your last assignment in the GWT assignment. And really I guess that's kind of the focus for your next couple of weeks here. And I wanted to start out though, if there's any questions either about Project 4, which is due tonight, or anything about GWT or the katas or the screencasts. I guess one thing, grading this weekend, some other things. And so I didn't put together a lecture, or I didn't put together slides, a screencast for the dependency injection stuff. It's not crucial to your assignments, and it's kind of nice stuff to know. But I figured it was better to get you guys feedback on your projects than it was to listen to myself talk about dependency injection and juice and stuff like that. So apologize not for having new content, but I think you guys so now you can work on your project more instead of watching that video. So sorry, that's what I got. Any questions from you? No? How was Project 4? So lots of good questions going by on the community. So that's good. Does everybody sort of feel comfortable with REST making HTTP calls and all that stuff working? Okay. Good deal. So tonight I want to spend the entire time working on a coding kata. I've been thinking a lot about sort of what we did last week, we did the week before. I want to continue the experiment. I like what I'm seeing. I know that I personally am learning quite a lot working with you guys, and I like seeing the solutions that you come up with. What do you guys think? Is this, well, you showed up and you knew to expect, so you felt compelled or you're actually interested? Which one is it? Interested enough? Okay, good deal. Seriously though, let me know. I'm here for you. I think working together in pairs on stuff is a good way to learn stuff and see stuff, but I want to make sure that's working for you guys. Okay, so without further ado, the kata that I selected for tonight, I think in some respects might be a little more bounded than the one last week. I think the one last week, the OCR, there was a lot there. And I know, even I think when I started digging into it, it's like, oh, there's, how do I organize things? And it was probably a little bit more than I wanted to do in sort of like a, 2.5 hour session. So I think I have something that will be a little bit more digestible by everybody, and that's the game of life here. Are you guys familiar with the game of life? It's it's a computery thing. It's probably something that every undergraduate should see at some point. So let's see here. 2. Okay, well, there's an even number of you guys tonight. So what I'd like you to do is pair up and review this the page on the Coding Dojo site here. There's a link to it in the Google Plus community. I've also started a Hangout. And so I'd like to sort of do what we've been doing the last couple of weeks, where you guys work for a little while, and then I think I'll work for a little while too, and then we'll all get together every 15 minutes or so and compare notes. Sound good? Okay, so let me set the timer here for, let's just take 15 minutes, and let's break yourself up into pairs. Feel free to pair. Actually, I would recommend that you pair with people that maybe you haven't paired with before. Just to get to know each other and get more experience with pairing with other people, and read over the assignment and sort of put together a plan of attack. Resist the urge to write code right away, but think about your design and think about sort of how things are going to work, and then we'll get together and talk about that briefly, and then we'll start coding. I promise. Okay, cool. So let's do that. Okay, so I'm just going to pause it real quick. Okay, so it's been 15 minutes. That's my plan of attack, which you guys can see if you want. But I want to hear what your plans of attack are. So I don't know. I just sort of ask these couple of questions here, like what concepts we want to model, behaviors we want to model. Do we want to model? What tests will tell us we've done the right thing? What do you guys think? So what do you got? How are you thinking about approaching this problem? What do we need to model here?
We need to model a cell.
Okay.
That parallelly, like have two states of that alive. It will have few methods which will be returning its states, setting its states, and with all the loops.
What was the last one? Sorry, what?
Updating its states based on the rules that it is, which is like a set.
Cool. Okay. What else are people going to model? What other classes are there that you're thinking about? Anything else?
A 2x2 board with the cell sits on some sort. Used, determining adjacencies, etc.
Oh, okay.
One question that I was wondering, like, how do we still need to find the position of each cell, right? Because unless we find the position, we cannot find the neighbor.
Right. So how do you find the?
That's what I was wondering.
Right. How do you find the neighbors?
By having the adjacent positions. Yeah. Like maybe we can have quadrant for each of those.
What? Sorry. What? Quartering?
Okay. Position X and Y.
Coordinates. Oh yeah.
Coordinates.
So like each cell would have its own coordinate.
Yes.
Mm-hmm. Does that sound consistent with what you'd be thinking about? Other guys?
Each cell will have a coordinate. Yeah.
Okay. So yeah. Oh, so like the board would know how to set the neighbors or figure out the neighbors.
Yeah, like as we iterate through, look at each cell and maybe have him communicate to his neighbors that he's adjacent, or ask his neighbors if he's adjacent. I don't figure that one out yet, but something along those lines.
Cool. Okay. Apparently, I can't spell adjacent tonight. Too many N's in it. Okay. Okay. Cool. So it sounds like you guys have a pretty good plan. What about you, other guys? No. You have a plan. We'll see how good it is. Yeah.
A simple plan.
Anybody else? These guys are already typing away. I'm guessing they probably got it implemented already.
We're kind of going between a couple of different approaches. One was to sort of have kind of an array that has the dimensions said and kind of somehow process the text strings and go through and start them all at 0 and kind of increment them going up as you read it in. So there would be like a reading in and then writing out, depending on the number. But there are some problems with that. You need more information. You need information about if it's live or dead and that kind of stuff. So, but maybe you can get that from the input. I'm not sure. But then we're talking about another thing too.
Yeah, kind of trying to store maybe all that stuff at once is kind of like in your array. So like because then you're not having to somehow go over data twice or something to figure out like when you read it in, is it alive? Or is it dead kind of thing? Like keeping it. So we were thinking maybe you start at 0 with dead ones and start at 10 with live ones so that you can distinguish and then count up instead of having a bad
Okay. Interesting. Okay. Sounds like a good approach. Give it a try.
We'll see how it works.
To bring input thought, can we implement the board as a two-dimensional array?
I think that's
Yeah. I mean, as long as the language allows you to do it, go for it. Yeah, it does. And yeah. Yeah, you can have arrays of arrays in Java. Cool. Okay. Anybody else? Thoughts they want to share? Ideas they want to bounce off? Everybody else?
Well, from reading it, I was thinking kind of like, or we had talked about the fact that it could just be like integers, like a two-dimensional array of integers.
Yeah. Okay.
And then store them as one, then you actually would just count your neighbors simply going around, and then
Then it's just a simple comparison after that too.
Yeah.
Four rules.
so each time you go around
Yep.
to the neighbors, you would check to see if it's gone above what is appropriate for what. And obviously below if you reach the end of all your neighbors. You have to do the bounds checking to make sure that you're not.
Right. Yeah.
If you don't go too far, if you don't go below 0 or above your size.
I guess we can go.
Yeah.
And
Index.
we made an assumption that our diagonal was our neighbor.
I think that's correct. But it's you have each cell has up to 8 neighbors.
I forgot about the bounds.
Good deal. Okay. Actually, I think we pretty much covered behaviors too. So, okay, how are you guys not test it? So, what are some of the interesting test cases that you want to make sure work?
Well, 1 through 8 neighbors.
Okay.
1 through, or 0 through 8 neighbors.
And what would you validate in this case?
Well, then if you
Can
started,
you close the door since you're over there? Thanks.
if you started with, if you were alive previously, so if you started with life, and if you had 2 neighbors, then or less than 2 neighbors, you would move on. So there's a whole bunch of cases.
Okay. Oh, right. So basically, figuring out like, hey, how many neighbors you have, and that's where you do all your boundary conditions and stuff. Yeah.
Yep.
Okay.
Favorite cellular automata.
What was that?
Checking that you read it in, right?
Right. Yeah. Validating, reading text correctly. Cool.
Yeah,
Okay.
so parsing.
Yeah. Right. Yeah. Our old friend text parsing.
I guess opening and closing file as well, if we're going to read it from the file.
Yep. Okay. Okay. If you're on the Hangout, there is a document that I'm pretty sure I shared. Actually, is anybody on yet? Can you guys see it? Okay.
He's up to
Okay. Right. Yeah. Right. I heard it. Say that. People see it on the. Wait. One new. Oh. So maybe I haven't. Okay. So I'm not getting the hang of this here. I'll invite you guys again. Oh, somebody got it. So is that you, David? Yeah. Okay. Okay. So is the invitation up there? On the community? Okay. Oops. Close the Hangouts. Okay. I guess it just hasn't hit mine yet. Oh, there it is. Okay. Awesome. Okay. Anyway, I created a document here, and if you scroll down to page 2, actually now my screen's getting a little slow. If you scroll down to page 2, there's my plan of attack for what it's worth. I don't know, these are just ideas that I had. I'm not going to cover them all right now. But this is the plan that I'm going to work for, some ideas that I had. But, okay. Well, shall we get started then? I think everybody's anxious. I'll put the timer on for 15 minutes, and we'll check in and see where everybody's at. Hey, how's it going?
Hey.
Okay. So yeah, here we are again.
And in this cellular automata, you can never have 0 neighbors. You can have a minimum of 3.
Right, if they're in the corners. Right.
Yes.
Right. Okay. Cool. So, do you have a laptop with you?
I do.
Okay.
But like I said, this is one of my favorite cellular automata. I did it in,
Oh, cool. So you got experience with this.
yeah, I was in
Good deal.
complexity science.
Okay.
So unfortunately, it was loaded up as a template, so it's not like anything I had to, go program crazy on it.
Well, we're going to program crazy on it now. So.
And even then, the net logo isn't the same as programming in Java. It's just like Java. You have to define these are my objects, these are my, but they're defined predefined objects. Like these are my turtles. And it says, okay, well your turtles look like this normally, unless you tell it look otherwise.
Awesome. Okay, so let's get my Maven project get started here.
So we'd need a field that is 3 by 3. No, not 3 by 3. You'd want it what is it, 5 by 5?
So this, we're getting these.
To start, isn't 3 by 3 good enough?
3
Won't
by
that
3 is good
give
enough
you-
for test purposes, because then you'd have
Right. So here, here's what I was thinking for my plan of attack. Let's see if I can find it here. That's my. Who cares if I'm muted? Actually, I'm mute my video too. Don't even watch me pick my nose here. So I was thinking is that okay, that we'd have a generation. I'm calling each one of these things a generation. So
Yes.
the board. So a generation that essentially has a two-dimensional array which says what things are alive and dead. And I think the first thing I want to do is basically implement a functionality that says, hey, how many of my neighbors are alive? Right, and because I think that's basically key to each one of the rules for evolving to the next generation. So that's what I was going to start out with. And one of the things that I'm trying to figure out is, well, let's just see how the code looks. Because I'm wondering, so hard for me to talk and code at the same time. Actually, we'll start. So instead of app test, we'll rename this generation test. And this is like an old style test case. Let me just use. Okay, so I got to change my Maven project to use a new version of JUnit, like 4.5. Okay, and then I need to regenerate my Maven project so the dependencies right. I forgot about that. Oh, and I probably also want to add the want to add ham press so we can get the nice matchers and stuff. Format that. That's better. Regenerate idea. Reload the project. Yes, everything's changed. Okay, better. So generation test. So let's see here. So I think, what do you think? When we have a test, and we'll say, we'll have these 3 by 3 grids. We want to figure out like how many neighbors each one has. So like, what's the first test there?
Hey, I remember in NetLocal it was simply ask turtles how many neighbors do you have, or ask
Okay,
neighborhood.
so it's like, well, let's just do something with no live neighbors.
Yeah.
Cell with no live neighbors.
Perfect.
Okay. So let's see here. I think we should have a little text description of it.
I think that would help.
Probably make the test most
Because it's a
easy
3 by
to-
3 grid we're working on for
Yeah.
starters, number 1 would have a possibility of having 3 possible neighbors. 2 would have a possibility of 5. 3 would be.
So if everybody's dead, everybody's dots. Is dead the dot in the? Oops. Let's go back to the kata here.
So that is a
Yeah,
lot.
dot is dead. Okay. So it's, yep.
One thing that would actually help make this a lot better for your
Yeah.
tests is if you make the dots count as either zeros or ones, and then the other ones for the opposite. So we have a binary input, so you can make a simple math. If x equals 3, then drop dead.
Oh, okay.
Pop
So
dead.
like if you had like a. So should I represent it as? You think I should represent it as strings, or should I represent it as like an array?
My money's on array because
So even in the test, I'm just wondering. It's like,
Yeah.
would this be easier to read? I think this would be easier to read actually,
okay.
and so I think it'd be more intuitive what the test does.
Okay.
Let's see here.
I was gonna say I'm just coming from a complex science where we deal specifically with zeros and ones as our primary form.
Well, internally, I was thinking about representing them as an enum type. Again, mainly just so it's easier to read because like a number.
Yeah.
I can see where. Yeah, it's like, am I erring on the side of making the code, what I think is readable or whatever? Or is it just sort of add extra complexity? Let's find out.
Because I know NetLogo specifically it'll handle numbers, it'll handle variables, it'll handle anything you tell it to.
Mm-hmm.
But its base format is basically a Java kernel with handling zeros and ones and just simple if-else statements.
Okay, but well, how much of that kernel would you have to like rewrite in this green field?
a lot because
Right, yeah.
because it's a Java kernel, but its actual what it reads and then compiles into Java
Because
is
it got its own little language and stuff
Yeah.
like that, which we don't have here.
it's a sub language basically. It's like okay, populate, generate, then run.
So what I guess ultimately what I want is a generation. And I guess I got oops. What is it saying? Create class.
Right, if it's out of
There,
bounds.
okay. And then, so I want to parse this string. I think I might need to use. I might need to create a text parser. I think we're going to implement that functionality first before I can really start working with the generation. If we're going to read it from this, and we'll do that
Yeah,
anyway.
that
So let's do that
works.
first. Okay. Okay. So then we'll come back to this. we're not quite ready for this test yet.
Or the one right above it.
Okay. So now we're going to need. I'm going to put the parser stuff in its own class. So I'll create another test class, which will be generation text parser.
Absolutely.
Test.
That's fairly
I think it
fairly
says what it
understandable.
does. I think so. Okay, so
It's less than 0, then we return false.
so we'll say public void, and what we really want to be just like parse parse text. Well, parse. So like all dead. Sure. Parse all dead cells. Right. So let's take this example from back here. Oops. And we'll say what we'll create like a generation text parser equals new generation text parser. Let's create it first. Generation text parser, and then let's it's got to take. We got to be able to read that string. So like there's what, a string reader class.
Sounds good.
A string reader. And it reads from a string, so I'll read from the grid.
It's my opinion that we're
Pass that reader into here. Nah, well, let's see. Do we want to pass in the constructor? No, let's just do the following. We'll say return to generation. Generation equals parser.parse, and we'll give it that string reader. We don't want a string. We want a reader. Let's call it reader. Throw new unsupported operation exception. Yeah, it's not implemented yet.
This is where we have to make it.
And then what we want to assert that generation. So now we'll say, hey, each cell should be dead.
Yeah.
Right. Okay. So generation dot get cell state of 0, 0 equal to dead.
You're just starting 2 by 2.
Yeah.
The way we can have
No, it's something called dead.
1 by 1.
Okay, so first we need get cell state. So that's row, column, and it doesn't return this. I want to return something called the state. Oops. Maybe I should call it a cell state. No, I just want cell state. No. Come on, IntelliJ. I want to create a enum called cell state, and sure, let's have it be a top parent thing, and I want it to either be alive or dead.
Works for me.
Okay. Yep. Okay, and then we'll. This isn't implemented yet. Throw new unsupported operation exception, and then. Yep. Cell state dot dead. Okay, now I gotta do some imports here.
It's kind of the same thing. I think I did it.
Oops.
Why is that not going again?
The stack import method. There, now it's all happening.
Aha.
Okay,
Good old
so
italics.
yeah. Okay, well, we can refactor this later. Okay, so now let's try to run this dude.
And we're going to fail.
Yep, that's the plan anyway. How are we doing on time here? 3 minutes. Okay. Okay, unsupported operation exception. It couldn't parse it. Okay. So now let's see if we can parse it. Let's see here, generation. Okay, so first we're going to need to create a new generation. Equals new. Oh, you know what? Our text isn't right because our oops. Generation. We need to have. If you look at the look at this thing, there's like. Oops. You have to tell the number of rows and columns.
Yeah.
So it's like, do we need that in our tests? That's kind of weak. Here's what I'm going to do. Oh, wait. Oh, and you know, I don't have new lines or anything between this.
So what does the /n do here?
That's a new line
Ah,
in the string.
gotcha.
Okay, well, so let's just, heck, for the sake of it, put in that this is a 3 by 3.
And that was the, if the neighbors are equal to 3.
Okay, so then the first thing that we need to do, well, okay, actually, there's something that we can do even before that. We can say assert that generation dot get number of rows equal to, and I think we're going to need this. Yeah, equal to 3
So this case is just equals.
and
Change that to it too.
okay, and throw new unsupported operation exception, and then number of columns also equals 3.
But this one
So you can say if it is dead.
Oh, yeah,
We can put another friend in there.
Okay.
Or
so this is.
if you want. It's kind of.
So actually, you know what? We're sort of seeing. I think we're seeing another test in here. We don't even need to be testing this dead stuff yet.
Yeah, because we're working on
Yeah.
just getting it
So the
to
rows and
spit out 3
columns.
by 3.
Yeah. Okay. Well, let's
Otherwise you would call it.
let's. Do I want a separate test? Let's just comment this out for the time being, and let's see if we can get this much. So what isn't like here? Oh yeah.
And has precedence.
There we go.
It's having a hard time parsing the first line. I'm trying to skip over.
Okay,
it says generation,
so let's see here.
space.
Oops. And then return generation. Okay. So now let's parse the. So let's see here. We need a buffered reader so that we can know. Buffered reader.
Actually, that's the only, those are the only cases.
BR equals new buffered reader around
So
the
basically
reader.
just do if this,
And then let's see here. I'm not so worried about robust like error stuff and everything right now, so I'm just going to cheat a little bit. I'm going to say first line equals BR dot read line, and then oops, let's break up thing about some exception.
Yeah, you say.
And then so we want what? So we'll do a oops.
Alright, RAM. Let's see what Gates
So this ended up.
And then split on that,
Okay, what I want.
and then int rows equal row. Oops. Integer dot parse int row and column 1, and then oops.
On tablet, so
When we,
Throw together some
Columns equals this new generation rows columns. Create this constructor. Nice. And let's see here. I think I can say turn this guy into a field really easily, right? Create field for parameter rows. Nice.
With unit testing, these functions.
Create field for columns.
Yes, alive.
and then get number of rows, terms,
Let's say we're at.
this dot rows,
Yeah.
Oh,
you
yeah.
should.
turn this dot columns. Okay. Okay, so I think we have everything implemented. Let's give it another run. Oh, it doesn't like that. Needs to add exception. Okay.
So here,
Hey, everything passes. Okay, so we can parse the first line. So let's let's rename this guy. Let's do a little bit of refactoring here. Let's rename this test to be parse row and column. Okay. Awesome. Oh, I need to add some stuff to Git. It didn't. Surprisingly, didn't tell me. Okay. Well, anyway, let's. It's been 15 minutes. Hey guys, it's been 15 minutes. Let's do a check-in. See where we're at. Let's see here. How about we get up and we'll turn it over to the.
Absolutely.
Yeah. Okay. So who'd like to go first? Who's on the hangout already? Sean or Parkson? Hey, who wants to go first? Who has stock? Where are we at? Do you want me to go first?
Sure.
Okay. Well, okay. So we the first thing that we first started writing a test for a class we called Generation. And so we're like, okay, we'll have a test that's like, hey, cell with no live neighbors. And so I was thinking, oh, the first thing I need to write is here's the number of neighbors. And I quickly realized that, well, I wanted a nice way of representing what the generation with the grid looked like. And so I had this nice little string made out of dots. And then I realized I have no way to parse it. I'm going to need that anyway. So then I went to I started writing another test, which was for a generation text parser. And then I remembered that the format for the grid had the row and the column. So what I've got so far is a generation parser class that knows how to parse at least the first line of a generation and assert that it gets the number of rows and columns correctly. Although, you know what I should do in this one? I should have a different number of row and column just in case I mess something up and I've got the and internally I store the same number in the same place. So I'm going to run this guy again. Okay, it's all green. So that's as far as we've got. How do other guys do?
Yeah, we can share real quick.
Yeah.
Let me, hop on the hangout.
Interesting that this guy didn't. My project didn't pick up that it was in Git.
Here,
Do I have a target directory?
because that
Oops.
it was assigning an IX and then subtract.
So who's up?
I think we might have everyone's supposed to die. Is everyone supposed to die?
Is everyone supposed to die? Everybody dies eventually, I guess. It's kind of morbid.
Well, we have what was hopefully working. It looks like everyone died and don't think they were supposed to, so it's not quite working correctly.
Would you mind coming up here so that it'll project and we can get it on the microphone?
All right, so to start with, we are representing the actual game map, which would be this guy here, as basically just 0 if it's a dot and a 1 if it's a star, for 1 being alive, 0 being dead. So at first we just kind of read it all in, just read each line, and then just kind of assign, at each position. If there's a dot, give it a 0. If there's not a dot, then we can just give it a 1 because it's alive. So once we've kind of got all of that read in, then we make a new grid because that's where we're going to copy. That's where we're going to that's where we're going to save the next generation at the new grid. And then at the end, we'll just assign grid to new grid. So once we have the new grid, then we're just going to iterate through each position in the grid. What's that?
Make it a little bigger.
Yeah, let me see if I remember how to do that. I did it last time. Try to get rid of some of this extra stuff. Is that good?
Yep.
All right, so then we're iterating through each grid position, and we're just asking, am I alive? If I'm alive, then we're going to assign it a 1, otherwise we're going to assign it a 0. And so is alive, that function is just going to compute whether in the next generation that cell should be alive or dead. So then we come down here into is alive, and it's kind of a little crufty right now because we're doing some debugging to try to figure out why it's not working exactly like it should. But we're basically determining these like low x and low y, and high x. That's just determining like if we're going to fall off the edge of the array when we go down 1 or up 1. And then kind of assigning those values appropriately so that we won't go out of bounds. So once we've figured out the bounds, then we're just summing all the neighbors, which is what's going on here. And then after that, we're going to call. Oh, and then this is because we include the cell that's actually been calculated. In this neighbor sum, we have to subtract 1 from it if that cell is alive right now, because otherwise there's an extra 1, and we don't want that. So then we call this overloaded is alive function, and that's just going through the
4 states.
Yeah, through the 4 states that could possible, and we kind of combine them. So this is 2 of the states where they have less than 2 neighbors or more than 3 neighbors, then they should not be alive now.
And how do you find the neighbors?
The neighbors was what we computed up here where we did this neighbor sum. So then we're passing in that neighbor sum. So this neighbor sum is when we're iterating through, that 3 by 3 grid around the target cell to sum the neighbors, which is just if they're alive, we just do a 1. So if 3 neighbors are alive, then we're going to end up with 3 after that. And so then in here, the other one is where they become alive. And so there's a couple that it's where they're currently not alive, but the neighbor sum is 3. Then it's overpopulation, I guess. They end up being able to make a new one. And then the other one is just if they're currently alive and either the neighbor sum is 2 or 3, then they just stay alive. There's no change.
Yeah, we talked about putting that second state or the second condition in there as the only condition and have it false as before.
Yeah, it seems this top one is superfluous, but right now it doesn't seem to be working right. So maybe one of these rules is obviously probably not right. We got to look into it some more.
How do you know it's not working right?
Well, it comes out to all 0s with this one here. And it seems like when I get here, right, this guy has 2 neighbors that are alive, so it should stay alive.
Okay.
But right now, he's dying.
Yeah.
And then all the other ones are dying too. So maybe it's a drought or something, I don't know, but it's not good right now.
Right on. Plague of locusts.
Yeah.
That's where mine's at. Awesome. Thanks for sharing that. Woo. Come on, let's hear the love. Right on. Who wants to go next? Anybody else want to share? I know these guys over here already have it done. Come on. I want to see what you guys got.
What was the
refreshed
hangout
it
on it?
recently?
No, I haven't.
Okay. Yeah, it doesn't, for some reason, like the Hangouts don't. Scroll down a little bit. Oh, you're not signed in. That would do it. There. Video calls in this community.
Oh, there we go.
Yeah, which doesn't, I don't know why they call it Hangouts in this community. Everywhere. There we go.
Okay, I'm gonna set my font size up so you can read it. Is that good enough? Yeah, that's fine. So, started off by writing just a simple function from the data structure that we use. I just created a two-dimensional grid of Booleans. False meaning that spot is dead, true meaning it's alive. And so I created the function isAlive that handles cases where you're trying to check out of the boundary of the grid. So that simplifies all the logic of the for loop that I use later to loop through the grid. Number of alive neighbors does pretty much what the function name implies. You pass it the grid and a coordinate in the grid, and it tells you how many neighbors are alive. Then the actual logic is all just right here. You just loop through. You pass the state of the life grid before you simulate all the life. Just loop through it for each member of the grid. You count how many neighbors are alive. If the current cell is alive, then you check if it's the number of neighbors are less than 2 or more than 3, and you set it to the after value to false. Otherwise, you set it to true. Otherwise, if its number of neighbors is equal to 3, then you set it to true. That's basically the whole system right there.
Cool.
Got the code down here to load it, but it's kind of ugly.
Okay, so you're feeling confident that it works?
Mm-hmm.
Cool. How do you know it works? What gives
I
you
ran
confidence?
so far. I ran the test that was on the page, and it got the same output. Working on the unit test right now.
Nice. Okay.
That's all I have right now. Just testing the isAlive function.
It's alive. Awesome. So I noticed that both of you guys are using sort of static methods and things like that. I'm not seeing objects. I'm not seeing classes. I don't know if it's good or bad. So like, what led you to sort of have all of this stuff in sort of a more procedural style? Think it lends itself well to it, or?
I thought it'd be probably a little bit easier to write the unit tests, and I don't know. That's mostly it there, and also when having the simulate life function, it made it easier to make sure that the grid state before simulating didn't interfere with the state after.
Yeah, I think that's a really good point. I know when I was thinking about it, it's like, oh, if I have an object that represents it, it's got these two different states, then how do you model that? And so, yeah, I like having you send in, Boolean array, you get back a different Boolean array. Yeah, nice. Any questions or comments for these guys? Yeah, good deal. Anybody else want to share their progress or any questions or anything before we dive back into it? Oh, okay then. Let's do our 15 minutes. And, oops. Got it, okay.
Okay, so,
Oops.
what do you think?
Neighbor sound was always equal to obviously it's always going to be there.
Okay. So I was gonna commit these. First test of parsing the number of rows. Yeah, don't commit them. Okay. Okay, so let's see here. Where are we? Okay, so I think we've got this test. Now let's create a test that starts looking at which ones are alive and which ones are dead. Now I wish I remember the name of that because I kind of liked it. Was it all dead cells or something like that? So we'll use that same test. We don't need to test here anymore, but now we want to assert that the cell state at 0, 0 is dead. Oops, let's get rid of this. Okay, now let's run, was it option shift 10? Okay, red. Throws and all. Yep. Okay. Squared operation exception. Okay, so now what we want to return here is we want to return. Oops. Return cell states row column. So we'll create a field, yeah. Cell states, awesome. So now we need to, when we create the generation, we need to initialize that. Array equals new cell state, number of rows, number of columns, and actually well, we'll get to that later. Okay, so we've created that thing, and now if we run it, what do we get? We probably get some sort of random outbound exception or something. Oh wait, describe mismatch. Something bad happened there. What do I got there? Well, that's unfortunate. It says that it can't describe the error. I wonder if Maven tells me anything more interesting. Oops, I'm in the right directory. Kata, game of life. Test. Failed. Target surefire reports. Test one. Text. What is it telling me? No such method error. Describe mismatch. Blah blah blah. That's pretty messed up. So something must be wrong here with Hamcrest. I'm a little too impatient right now to try to figure out what that problem's all about. So I'll just debug it and. Oops.
This is going to check the value out here. Number of alive neighbors.
Oh, how come it didn't stop my breakpoint?
Outside of the bounds.
Sick.
Then,
Weird.
That should return 0.
Okay.
Oh, I'm not debugging it, I guess.
Here's an interesting one.
Increment text, right? Where do we just do X? Oh,
There we go. Okay.
okay.
So we're going to parse that,
Below there.
and then we're going to call generation.get cell state, and we will evaluate this expression. And it's null. Oh,
I'm satisfied with that function.
really? Null? I don't know about that. I'll put that into a variable and see if I get better reporting here. Cell state, and then assert that cell state null value. Yeah. Okay, so now let's try rerunning this again.
Sure.
It's still getting that no such. So wait, it's not null. Cell state, oh, is null, and so again, it's having some problem. That's really weird. Okay, so it's returning null. I guess that's not so surprising. So this is null. Okay. Anyway, well, I know it's null because I haven't implemented the parser. So let's implement the parser. So here now, okay, we're going to say for int row. Well, we're going to call it line. line number, oops, line number equals 0. Is it really the second line, but whatever. While line number less than the number of rows I plus plus. Oops, not I plus plus, line number plus plus. Oh, actually, yeah, we want line number to be 0. Actually, we can call that thing rows, can't we? So what, we're going to read a line. We're just going to call this thing row, I guess. Doesn't matter. Okay, so that's, oops, that's read line. It's going to read the line. And then for car C inline dot to car array. So every line, if we're that, we say, oh, boy, we need to know, sorry, we need to know each column. So int column equals 0 while column is less than line dot length, column plus plus. And then we say car C equals line, get that car at column. Oops. So we say if C equals dot, then oops, cell state.
All of these are going to stay alive.
Okay, so if the dot is dead, so state equals cell state. Not alive, dead. Else, if C equals star, then it's alive. Alive. Otherwise, throw a new legal state exception, unknown character, whatever C is. And then finally, we want to say generation.set cell, get cell state, and then say set cell state of row, column, and then state. And this is this dot cell states row, column equals state. Okay, so let's see here. Now let's try running test again. I think I get some exception here. No way, that worked? I don't trust it. Something doesn't seem right to me about that. IntelliJ feels different. All test pass. Well, I guess because I'm not doing this. Okay, so all dead cells. Okay, well, that's interesting. So it's okay, so now let's inline this guy. And they should all be dead. So,
Which they all currently are.
well, it's just testing 0, 0. 0, 0 is dead. Now, I have a feeling, my spider sense tells me that if I ask it about something else, that's going to blow up. Because I think I've missed a step. Maybe I haven't. Nope, that seems to work. Okay, so we get those two. So now I'm going to say for int row equals 0 while row is less than generation.get number of rows. For int column equals 0 while column less than generation.get number of columns.
Yeah, it's mirror image.
Assert that row column, oops, column equals dead. What is it like? Oh yeah, row, oops, row plus plus, column plus plus. Okay, now
This one has
Yeah, I already did that.
that all worked.
Those will get neighbors.
Wow. Okay,
This one right here has 3 neighbors.
I'm pleasantly surprised. Let's run all of them.
That's awesome.
Oh, next one. Yeah.
Okay, it ran both of them. Okay, so that seemed to work. Okay, well let's do something similar with all live cells.
Yeah, that'll.
And then let's do something like 3 by 3, and then just want to see using different data.
And then there's just gonna be 2.
No, and then it's gonna go 1 here, right? So this one's died.
Yeah, so there's gonna be 2.
Yeah, we can make it.
And those 2 are just gonna be like,
And also,
they're not gonna be
so we could go forward.
Okay, that was something screwed up.
Maybe. Oh, yeah, I mean, we'll stop there and we can check it out either for the active board too.
I really don't like the fact that this is like giving me this bogus.
I'm gonna make it small.
Bogus class path.
Yeah, I don't know what's going on there. Hmm.
so they end up
What about every single
Oops.
only the corners with it, right?
Debug this.
No, even the corners will have 3 though. Oh wait, so that'll be 5.
Freeze accepted.
So I think it's right, the corners
Generation,
will
cell
be
states.
for 1
Yeah.
thing.
Why you having two?
Oh,
Now I'm gonna slow
interesting. It
down.
looks like in debugging, it looks like everything's okay.
Yeah.
So then what doesn't it like? Oh, stupid.
This is like an island of
Because you said everything's dead.
Yeah, and do I need to create some sort of like custom matcher or something in order to?
Might not be a bad idea because this
Well,
thing.
Yeah, right. Oh, sorry. Continue your thought. I
So
think it's a good one.
it doesn't seem to have any way to differentiate what's alive and dead other than simply what we tell it is. This is all alive, this is all dead.
So ham crust.
I mean, it has no way to really test for it other than simply saying, you tell me this is this.
Yeah, let me quick do a ham crust
So,
match.
so create the scanner there, then I store the scanner dot next line, which that will store, that's gonna spam value. That will store this line, this entire line to the input string. Then I then take the input string, take the substring, starting at index 11.
Oh, well, so 8 equal to.
There, all the way up to the length of 10 minus 1. So that starts from here, it goes to 1.
Okay, well, okay. I'm not gonna spend.
Just to the left.
I feel like I'm in such a hurry, right? What I should do is go back and figure that out. And
Yeah.
okay, now everything works. Okay, so it looks like we can read everything in okay. So this is good. Let's actually let's take a minute and refactor this because I mean I see all sorts of like super duplicate code here. I think I want to refactor my test. I'm going to check it in first because I know everything's working. And I'll come back and refactor it. Anything useful there? No.
It's gonna be like that trial one. Not like a trial one.
This is okay. Parse dead and alive cells from a text file.
That's it.
Yeah, just hang around.
Everything else has.
Okay, now I want to do some refactoring of my test.
All right, so why don't we put
What I want to do is,
on the diagonal.
how about,
Oh, they're actually still.
Because-
so here's some code that looks like it's duplicate. So it's like
Oh, I see.
parse
It's writing the file each time.
generation
Because I
text.
only implement the generation number when it reads the file.
Yes, please.
That's why that's not in
I get 2 of them. Replace, replace. Okay, that's good. And then, oh, 15 minutes already. I want.
Yes.
Once you go down.
It's like it almost inverts.
Oh, because this is kind of cool.
Oh, yes.
Insert that all cells are.
And then, these guys
State.
constantly move. So these would eventually go off the edge.
No, because, or, yeah.
Okay, that makes things I think a little easier to
Yeah,
read.
because these guys are,
And then
these animations here are gonna be constantly moving.
Yeah,
So
Okay.
it's all on our
Let's try
grid,
running
they'll
everything
actually
again.
fall off the grid and
Man, that's
die.
crazy because it immediately inverts and it stays.
Yeah, it's just like I'm done. Maybe make one that like does random. Like make a random generation.
cool.
And just see what happens. Like instead of reading the file, let me see what you're
Where have we been going here? Oops, an hour already. Okay. Okay, it's been 15 minutes again. Let's take a little break and then come back and talk about where we're at. So let's take 10 minutes.